Now, to do this, you've got to think a little bit backwards, but y equals natural log x. Now, we don't know what that is just yet. I mean, I've just told you what it is above, but we don't know what it is yet, so how would you do that? Well, what we do know is that we do know that when I differentiate that, I get that, don't I? So I do know natural log now, so I do know e. So natural log is similar to e, isn't it? It's the inverse, I suppose. So can I rewrite that in terms of e? That's just from last year, isn't it? Happy with that? Stuff we did yesterday, natural log stuff. Now, there's a function, but I've got a function of x in terms of y. So when I differentiate that, I'm actually going to differentiate x with respect to y. Can you ever understand what I'm doing there? Differentiating x with respect to y? Because I've got a function of y with x. So what is dx by dy? dy. Does that make sense? When I differentiate, I'm differentiating my function x with respect to y, so that's that. But do I want dx over dy? No, what do I want? Okay, so I want dy over dx. So dy over dx, well, that's just the same as that. That's a fraction, flip my fraction. That's a fraction, flip the fraction. Everyone see that? So, and what does y equal again? That's y. So dy over dx is actually the same as 1 over e to the natural log of x. Everyone happy with that? Now, e raised to the power of natural log x, what happens? You can ignore that part, which leaves you with 1 over x. Okay?
Wait, I didn't get the last step.
Yeah, no one gets the last step. Maybe it's, I've got to look at that. I'll have a look into that, why that works. When you raise e to the power of log x, why the e in the log x? To me, it's just so simple. So I'll talk to Mr. Francis and get that. But that's, can everyone see that? Okay. So there's the proof of when I differentiate log x, natural log x, sorry, I get 1 over x. Okay? Happy? Now when you do that, when you actually differentiate, so I've got a log x, y equals log of 5x. How do you think I'll differentiate y equals log of 5x? What rule will I use? The chain rule, yeah. The composite function rule, yeah. So this becomes, dy over dx becomes 1 over 5x times 5, yeah, good, thank you. Good. Which is actually the same as 1 over x anyway. Okay?
So it'll always come out as 1 over x.
Not always, but if you've got a log 2x, log 1 over 2x, 2 cancel, yeah. But if it's x squared, it won't cancel. Okay. You be happy with that?